Good evening, everybody. My name is Kevin. Welcome to the ESP32 product journey, where we are working on building a commercial product, a consumer product, based on an ESP32 module and showing the entire process from hardware to firmware to backend and whole thing, start to finish, sharing that with everybody. Things that I'm learning, hopefully will be helpful that other people will find useful in the projects that they're working on. So let's first of all, get my stream open here. Oh, that's not what I want. There we go. Okay. Excuse me. All right, I need to catch you up on the little bit of work that we've done since last time. And before we do that, however, just an item of note that I've talked about in a few of the streams here about testing this thesis of trying to build an Internet of Things device without breaking the bank or needing large truckloads of venture capital money. And so this idea of how can I do things on a budget but make it high quality, and are those things mutually exclusive? I don't believe so. And so one of the things that I did, and I talked about in a previous episode, was working on the enclosure here. Enclosure design is going to cost you thousands of dollars. Then the molds are going to cost thousands of more dollars. And how can we save some money there? Well, the approach that I'm testing is I had this designed for $50 on Fiverr, and then I had some adjustments made to it so that it snaps together, and a few other things. And then I sent it off to a manufacturer, excuse me, and I need it to be, just because it'll 3D print doesn't mean that it's ready for injection molding. And I want to get this injection molded so the case is, high quality and it snaps together. And so again, just because it 3D prints doesn't mean it's ready. And so what they'll normally do is look at it and have you make tweaks, or they can make tweaks. And I found a place actually that said they'll make a bunch of changes for me at no cost. I also got the same changes quoted from an enclosure designer for, I believe it was $700 was the quote that I was given to make the adjustments that I need to make this ready for injection molding. The place that I found that does injection molding said, oh, one of our guys can probably look at it and make the changes for you at no additional charge. So I'm going that route. That's an example of, instead of spending well over $1,000 on enclosure design, I spent less than $100 using Fiverr to kind of get the general concept there as far as I could get it. And then it looks like, maybe, fingers crossed, the enclosure shop will be able to take it from there, get it ready for injection molding, and we'll be good to go. So things like that, trying to save money and filling you in on that process. Now, something that caught me off guard this week is about 2 weeks ago, I got all my displays for this batch delivered. These are let me show you. These right here, these 1.54 inch, 200 by 200 pixel displays. I got a whole bunch of them, 560, 540. It was great. One of the things I learned was you have to have I don't know what it's called with US Customs for anything that comes through from China. So I had to provide the EIN number of the company that I'm running all of this under, and to get my package out of customs. And I did that. That was about 2 weeks ago. And then just yesterday, I got this FedEx duty and tax invoice telling me that I owe them $177 and, I don't know, 34 cents, 13 cents for getting my package into the United States from China. And apparently, according to the invoice, this is just standard. You bought it in China, and this is the tariffs everybody's talking about, right? Like you gotta pay to get this stuff into the country because it's not made in America, and we tax those things. And so that caught me a little off guard, and it's kind of interesting. FedEx says we delivered the package to keep the deliveries fast, and then we expect you to pay. I don't. There's like a little frequently asked questions thing in there, and one of the questions I was hoping to find on that was like, what if I just don't pay it? They're gonna like our suit's gonna show up and like confiscate my e-paper displays. Like I'm assuming now that they have my EIN number, the next package I try to bring in through the through FedEx, they would just hold on to and say like, sorry, you still owe us money from the last package. I'm guessing. And the paperwork actually it just says if you have questions, call FedEx. And so not something I was expecting. It's $177. That adds, whatever, a few cents to each display because I got to pay for that on top of the shipping that I had to pay to get them here. So things that you learn as you go. You're going to get hit with customs once you're over a certain dollar amount. Like, because I've ordered tons of stuff from China before and never had to pay this. I think I just went over a certain dollar amount with my display order. And you gotta pay the tax man, I guess. So just wanted to inform everybody about that. Beware of that if you're going to make a bigger order from China. Now, the other thing that we need to cover are the changes that we've made since last time. Again, we are working on making changes so we are USB compliant and that our charge current is correct in all the different scenarios. And so let me just go through those briefly. I changed these resistor values. Again, I'm not going to go over all those calculations again. 400 milliamp charge current, just over 1 amp max current to consume over the micro USB. I've connected these BCD lines. These are from the FTDI chip. The BCD is for when the battery charger is detected, and it will pull that low. So by default, the charge enable pin on our PMIC is pulled high over here to 5 volts, which means charging will be disabled unless the battery charge detect line on the FTDI is asserted, which is active low. So it will pull this to ground, and that will enable charging. That should only happen when a dedicated USB charger is detected by the FTDI chip. Same thing over here. We'll use that same signal to pull the enable 1 pin low. And then the power enable is pulled low when the FTDI chip successfully enumerates on a host, a USB host. And those pins flipping a certain way controls the maximum amount of current from the USB input that the PMIC will charge. It'll use the battery for everything else. So those are the changes here. Another change I made here was this VBAT. This used to be the JST connector was right here. And so I removed that and made it a hierarchical pin so that it could be an input to this block of the schematic. And so if we come out to the higher view, you can see I put the J2 out here. This is the actual battery connector that will come in. And now VBAT is just an input to this power block. And the reason that we did it that way, I will explain in just a second. So now we have another input to our power block, which is that battery. I added the battery charge detect and power enable as tri-state inputs to this. I guess these would just really be inputs. It doesn't really matter. It's just a symbol. And here they are coming out of the FTDI chip. You've seen this before. There we go. I pulled these off the C-bus lines. Did a whole episode on that. You can go check that out and how we're going to use those. And so those come out of the FTDI block and into the power block to control charging and when charge enable is active. So those are the changes there. And then I named this net VBAT and came over here. And what we're going to try, and we're going to test this tomorrow. So tune in if you want to see me test that. We'll see how far we get tonight on that. But anyway, the VBAT is going to come into this voltage divider here. I'm using 100K and 33K to take a maximum. So when the battery's fully charged, it's at 4.2 volts. And this resistor voltage divider circuit right here will take 4.2 and put it down to just below 1.1 volts, which is the default analog to digital conversion reference voltage on the ESP32. It's 1.1 volt. Now you can compare and do an ADC on up to 3.9 volts, but the native ADC voltage for the ESP32 is 1.1. So in our case, we can divide that down to something in the range of 0 to 1.1. And so we're going to try this, and I'm going to test this tomorrow. And we might write some code on that this evening, actually, to basically feed this into an ADC pin on the ESP32 and read that to determine what our battery level is. And so I'd like to be able to get a charge indication on that based on the voltage so that we could, in the firmware, maybe do some smart things around detecting low battery and reminding people that it's time to charge their device. So that, I believe those are all of the schematic changes that we said we were going to do. Let me just look at my list real quick, see if there's anything that I left off. Yeah, okay. That is it. And then if we come over to here, you can see, and I don't know how to, there's probably a way to do this, but because I moved the JST connector, you can see it like, this one's no longer used, although it's got lines going to it. So why is it still used? That's interesting. I wonder if I can just do this. No, it doesn't. Okay, well, delete extra footprints. I don't know what that is, but what we'll do is we'll just remove that one and use this new J2 over here. It's even got the same, you can see it's upside down because it's on the bottom of the board, but this is J2 here and this is J2. And then these two extra resistors. So we have to, we'll put this in the exact same spot, and then we've got to find a place for these two extra resistors to go. They're going to go into pin 7 here, so we'll probably sneak them in somewhere around here and maybe have to reroute this enable line a little bit. We'll do that all in a stream. We'll make all of the routing changes so you can see that it's kind of like solving a puzzle. So yeah, that's where we're at. Hardware wise, I think we've got all the changes that we need. Oh, one additional thing that we're going to do is we're going to put in test points. And I learned about this today. So for example, if we wanted to have a way to look at the voltage at our ADC input here, I found in newer versions of KiCad, if we insert a part, and there we go, I already searched for it. You just search for test point and hit OK, and you'll see that it creates one here. And let's just say I want a test point right there. Now what we can do is we can save that. And we need to give it a footprint. So we come in here, you can see it has no footprint. So if you try and go over to the PCB view, it'll say, hey, you don't have a footprint associated with that part of the circuit. And so we come in here and we just click on the little books. We've got a bunch of different footprints that we can use for a test pad. Normally they're just little circles like this, and 2 millimeter, that feels kind of big. 1 millimeter, 1.5 millimeter. Anyway, we'll mess around with the size here. Let's just say 1.5 millimeter, like that. And we'll hit OK. And I think that's all we need to do. We can come over here to this and then update it. Oh, it's going to want to annotate. So we'll keep existing annotations, annotate that. It's going to give me TP1, test point 1, add the footprint. And go ahead and update PC. There we go. Close. Oh yeah, see, look how giant that thing is. Okay, yeah, we got to go way smaller. It's huge. I mean, compared to everything else. So yeah, so we would have these, and then we could put test points in wherever we want to. So that's kind of a cool thing. We can also put these, I suppose, on the bottom of the board. They don't necessarily have to be on the top. Yeah, they're going to need to be on the top. We'll find spots to stick test points in. So anyway, that's something new that I learned today about how to add test points for making, messing around diagnosing things on the board. It's also common to build like they call them pogo stick test beds, to where you have these they're conductors, but they're on like a spring. and so they retract, but you make a little jig that has them positioned at just the right points that match points on your board, and then you can push it down on, kind of attach the board to it into this test bed with these little pogo pins on it that touch all the test points, and then you can run, you know, a firmware on that looks for certain signals and things to happen. It's just like an automated way to test things. So anyway, well, like I said, we'll add test points. We're not going to mess with that right now. In fact, I think I can, let's do Control Z. Yeah, we'll do that. And then I don't know that I want a test point right there, but we'll see that. So anyway, that's where we're at schematic wise. I think we're there. I think we have all the changes that I want to have in place for the next run. So, and like I said, tomorrow we're going to actually test this. And why don't we right now, let's make that what we do right now. Let's write some code to do that. So I don't have my overhead cam set up. I'll have it set up for tomorrow. This is the, there's way more on here than I'm actually needing. But anyway, I've created the voltage divider on here with 2 resistors. The capacitors and stuff are from something else that I did another time. And I'm going to hook this up to our board here. I'll tap off of the battery just from the pin right here on the front. And what I want to do is I'll charge a battery all the way up to 4.2 volts, and then I'll put it on there. And then what I want to do is I want some firmware to run that is pretty battery intensive. So in the actual application, very battery sensitive. It goes to sleep, deep sleep, in fact, to take very little current. For this, I want it to pull, as much current as I can reasonably. And so like I'll leave the Wi-Fi radio on. I'll probably constantly hit a web service to like get that transmit and receive current on the Wi-Fi up in the 200-300 milliamp range. And then I'm going to sample that ADC for a full battery all the way until it dies. And so hopefully that doesn't take, if I can pull a pretty consistent 200-300 milliamps, it should only take maybe 3 hours, 3 or 4 hours to kill the battery. And so I would like to, the requirements for this test are to do that and to graph the battery. And we should see, it shouldn't be linear. Yeah, it shouldn't be. It should be kind of mostly linear, and then it should kind of drop off, assuming this all works. And so let's do it. Let's figure out how we want to put that together. So we're going to leave hardware for now. We've been in the hardware heavy, and now let's write some firmware. The firmware for the actual product is all written through the ESP IDF. For something like this, which is just a little test program, I'm just going to use the Arduino IDE. And so let's open that up. And, I'm just going to use the same sketch. What I'm going to do, however, is I need to connect to Wi-Fi. So I need to get my credentials off screen here. No, it's not. It is new tab. Yes, and I want this to be credentials.h. Great. And I'll put my Wi-Fi credentials in there so that I don't expose them. Okay, now I can pull it over here. Okay, and so this is that sketch we were playing with the other day. And now what we're going to do is I'm going to actually copy this from another sketch. This is my deploy the fleet stuff, which we will get back into at some point. We'll do that. And we'll just get rid of all the deploy the fleet-ish stuff about it. And setup, say battery test. And this is that. That's fine. We can write that setup wait. We don't need that. That'll connect us to the Wi-Fi. And then once Wi-Fi is connected, we're going to do stuff to like check on the battery. So I think that's good. We'll just, for now, let's do serial.println connected and then delay 2000 just to make sure that this is all working. Here it is. Let's go ahead and program this. Upload. So this should connect unqualified token. Say what? Dot. Wi-Fi multi. Excuse me. Wi-Fi.h, this should all be right. Oh, haha. I didn't define Wi-Fi multi up here. We need an instance of it. There we go. That ought to fix it. Okay. And you know what we should do is you can't see all the way over there anyway because my head's in the way. So let's do this. Then we'll pull this down to where my head is, right there. Box me in. Okay, battery level test connected. So it's connected to Wi-Fi. Great. And again, as I said several episodes ago, this is a great example of how the USB port on your computer is not limiting the current. This thing is not asked for anything more than 100 milliamps. Which is what the FTDI chip is currently programmed to request. And it's definitely pulling more than that if it's connected to Wi-Fi. And so, but the computer will happily give you that amount of current. Excuse me. Okay, great. So I'm going to unplug this. Our sketch is working. Now what we need to do is we need to do a couple of things. So let's, we'll pseudocode in here. Like what we need to do. So we need to read the, I'm used to doing Python at work. Read the ADC for battery level. And then we need a way to log it and graph it. And there's 100 ways we could skin this cat, but let's take a look at, here's what I was thinking. Because one way that we could do this is we could just take the ADC reading, output it over serial, and then have a program running locally that just collects that into like a CSV. And then we could display that in something like LibreOffice Calc. But we could also display it in a Google Doc, and we could connect to a Google Doc through IFTTT. And I think that's the way we're going to go, because then we're reading the ADC, and then we're using the internet to log it, and that's going to help with that, using the battery up, faster. And so I don't know if I remember my login to IFTTT. I'm going to do this off screen. Wow. I remembered my username and password. It's been a long time since I've done that. Okay, cool. Now we need to okay, let me I don't know how to, yeah, maybe later. I'm not sure. I'm gonna pull this over here against maybe my better judgment. We need to manage your applets. Got it. I want to create a new applet. If this add. And what I'm going to do, oops, sorry. I think we can do a web hook. Receive a web request. This trigger fires every time the maker service receives a web request to notify it of an event. For information on triggering events, go to blah, 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 blah. So yes, I want to do that. And the event name, I'm going to say is battery report. Now I'm going to create trigger. Then that. I'm going to hit add. I'm going to say, whoa, Google Sheets. I'm going to say add a row to a spreadsheet. A new spreadsheet is created after 2,000 rows. Okay, so that's helpful information. If we do calculator, if we do an update every 5 seconds, because again, I want this to be fairly battery hoggy. Pelham, what's up? Great to see you again. We're working on creating a battery test firmware that will continuously check the battery level using a new circuit that I'm looking at adding to the hardware to see how accurate it is tracking the battery level of a fully charged battery as it consumes through dead. And right now I'm working on setting up an IFTTT, if this then that, applet that I can hit with my device with a battery level, an ADC reading, and I want to add it to a Google Sheet. So I'm using the Wi-Fi to do that and hopefully be able to then in the sheet graph that over time to see the discharge curve. And it should match like a normal lithium discharge. And if that all works, then we know that the circuitry that we're about to add to the hardware is good to go, and we will include it in the next hardware run. So that's what we're working on this evening. And I just was reading that 2,000 rows will create a new spreadsheet. I'd like it to all be in the same spreadsheet. So if I'm checking every 5 seconds, that's 12 times a minute times 60, 720 times an hour, which means we're only going to get less than 3 hours. Less than 3 hours until it creates a new sheet, a new spreadsheet. And we need, I think, yeah, that's also a good question if there's a rate limit on it. That's probably a little aggressive. So let's say every 20 seconds. So it's going to be 3 times a minute times 12. It's going to be 36 times an hour. I wonder if that's going to be enough. I could always just hit some other web site, just like ping something to use the battery. Yeah, like 30, I think actually even once a minute is probably enough. Nah, let's do twice a minute. Let's do every 30 seconds. Okay. So twice a minute, Or no, 3 times a minute. What did I say? 3 times a minute? There's 60 minutes an hour. That's 180 times an hour. That's 11 hours. That should be more than enough to kill the battery, or at least to give us a view of what the battery looks like. Twice a minute. We're going to do twice a minute, so we don't even have to mess with it. That'll give us somewhere probably around 15 hours until it creates a new spreadsheet. And again, it didn't say when I created the webhook that it had a rate limit. That's a good thought, though. I guess we'll find out. Okay. This action will add a single row to the bottom of the first worksheet of a spreadsheet you specify. Great. And how we would like to do this is this action will add a single row to the bottom. Spreadsheet name. We'll call this ESP32 battery test. Occurred at, we don't really care about these things, but that's okay. I'm going to actually open up on the other screen here, my drive, to see if I think I already have a, oh, look at that, IFTTT maker. Oh, I have maker. So let's do, oops, that, because I already have a folder. Great. I'm going to do this, ESP32. And then event name. No, I don't want to do that. I just want to do this, period. And I'll actually make the folder myself in that area. It's the ESP32. Great. And then value 1, 2, and 3, we don't really need. I don't need the event name either. So I think I can drop values 2 and 3. And I don't need the event name either. Like, just occurred at in the value. Like, this is what time it was, and this is the voltage. Just like that. And I think we can create an action. It's probably going to okay, continue. Applet title. ESP32 battery tester. Receive notifications. No, I don't want to receive notifications when it runs. Finish. Okay, great. And now what I'm going to do is I'm actually going to pull this off screen because it's going to have a specific endpoint that I don't want somebody to watch and then mess up my test by sending random webhooks to it. Okay. And so I need to find like how I hit the webhook. Like I forget how this works in IFTTT. Oh, I can't have any more applets unless I have row. Okay. I think it's my services. Webhooks. Here we go. Okay. And there's my key. Okay. And then I need my key. Okay. I think I've got this. What did I say? Sorry, I've got I know I'm off screen here with this, but it is showing me like my IFTTT key. And I just need to remember what I called it. I called it battery underscore report. And then I pass in the values. Okay, so I've got I'm going to pull this off screen for just a second. And in my credentials, I'm going to pound define the IFTTT endpoint and paste that in and save it. Okay, and that has the endpoint that I need to hit. Bring it back over. And so I just saved it in that credentials file. So in IFTTT, you can go into your webhook settings and it'll show you like this is your API key and here's the URL to trigger, a certain event. And remember, we called that battery underscore report. And so now all we need is a way to post data to it in the form of some JSON. So it'll look like this. Value 1, and then the ADC reading. So we'll say it'll be in millivolts. So we'll say like 1. Well, no, it's not. It won't even. I mean, it can be in millivolts, but it'll be the whatever, some value, 5555, like that. And if we send it like that, it should show up in our spreadsheet. So, and it says we have to send it as a. It says as a string. I think I actually remember in the past, like it has to be a string value. Like it can't be an integer value. I feel like I remember that. Okay, so great. Now, all we have to do is figure out how to do that on the ESP32. And you know who's going to tell us how to do that? Post data with ESP32 Arduino. Random nerd tutorial. Do we really need to install Arduino JSON? I mean, I'm fine if we do, but do we really need to? Or can we just hard code it? So we're going to need to create an HTTP client. Yeah, see, decoding JSON object. I don't want to decode it. I think we can just hard code string it in there. Add header. HTTP request data. Our content type would be JSON, though. Oh, yeah, here you go. So we're going to want something like this. Just grab bits and pieces of this. And we're also going to need everything. We'll have to do an HTTP begin. So let's throw that in here. And I think that's it. Then the server name is the full. Yeah, okay. All right. So right here, we'll create a new HTTP client. We'll begin with IFTTT endpoint, which is what I saved in this credentials.h file. And then we'll set the content type to application JSON. And then we can just post, and I don't need this API key. Yeah, this is just the JSON. So we'll want to do value 1. Oh, look at that. They already have like value 1, 2. Almost like the example was for that. All right. And then let's get rid of all of this. Set for value 1. Oh, we don't need 2 value 1s. And we'll just set this to like, 500 or something, 5,000. So just to test it, and then we'll do 20 seconds here just to test. Save that. So HTTP client, did we have to include a header for this? That probably would have been way back up here. Yeah, right there. Okay. Include HTTP client. And we'll connect. And once we've connected, we'll say HTTP client begin to our endpoint. We'll add the header that it's application JSON data, and then we will post a value, I believe is the form that it says we're supposed to use, and see if it creates a sheet. And then if so, we'll come back and we'll start working on the how to read the ADC for our voltage level. Let's first of all see if this builds. I cannot believe that. Is it going to build the first try? Did I get all that copy and pasting and updating right? It totally did. Wow. That's actually pretty rare. There's almost always some kind of typo. Great. Let's plug it in and see if it creates a new Google Sheet for us. Oh, let's I should have put something in there. It just says connected. Oh, wait. Oh, yeah. I know why. Because we need to program it. But before we do that, let's do serial dot print line sent battery level. All right, let's program that. And it programs so fast. Okay, I'm over here I got my Google Drive open on another page here. Let's see, 3, 2, 1. It's gonna take a second to connect. I feel like that's taken a while. I feel like we should have gotten a sent battery level by now. It's not liking it. I would venture a guess that it does not like that it's HTTP. I would almost bet money that it, first of all, IFTTT will probably requires HTTPS. And is there a way, let's go to tools. Let's do core debug level info to change that. And let's reprogram and see if we get any sort of message. And then we'll switch it over to be HTTPS, and we should be able to do just kind of the same code. We'll have to probably put a cert in here, but that's not a big deal. Let's clear the output. Look at that. There we go. Great. HTTPS expected protocol. Yeah, okay, great. Okay, so my money was bet correctly. That's exactly what was happening. So now we need to come back to our thing and do, you know what? Let's do ESP32 Arduino core. And remind me later. Okay. And I really prefer the ESP8266 documentation. ESP32 Arduino HTTPS client. We need a new cert. That's fine. I can actually probably grab the one that I use in deploy the fleet. But it's just HTTP client. And then connecting to Wi-Fi. Yeah, great. Huh. I wonder. So this is the same, right? HTTP begin. And it should have the suffix, which mine does. Let me just pull this off screen for a second. It is trying, but maybe because we don't have the cert, it just defaults to not doing HTTPS. But how did the cert get loaded? Root CA, where are we putting that in? HTTP client. Like this root CA has to get into, oh, is it part of the, there we go, root CA. Okay. Great. To save time, I've got a root CA in a project that I have up on GitHub, the deploy the fleet project. So let me just grab that. You can get this out of the browser as well. I'm just going to grab it from another right here. Copy. Let's come back over. So it sounds like all we need to do is throw a root CA certificate in here and then do this begin right here with root, what was that? What did I call it? Root CA certificate. Did I spell that right? And we're going to change this back to none. Yeah, okay. All right. Let's program it. Let's see what happens. Let's see if this baby works. Okay, we should get some output. Oh, the output's probably in the background. I don't know if this is new output or the old output. Oh, sent battery level. Look at that. Okay, now I should come over to my Google Docs and apparently see a document. I don't. I do not see one. So perhaps I have done something wrong. Go back into, so it's trying to send the battery level. Um, definitely not. Sending, unless I'm looking in the wrong account. No, I think I'm in the right account. Okay, so I've got something else. Maybe it's how I'm sending the data. Am I sending the right action? Battery underscore report. Let's make sure I've got that right. Okay. Well, stand by. We'll just work the problem here. Let me check out my web hooks. Like, is there a logging? Oh, it's not connected. Connect. Oh, disconnecting webhooks. What? No. Connect. Okay, it says it's connected. Real-time applets. Let's see. Check now. Check completed. View activity. No. Well, it seems to at least be sending and getting through, but it's not updating. It's not adding a row to my spreadsheet. So I've obviously got something wrong. So let me come into my webhooks and see if I can manually like curl. Event, which is what did I say? Report underscore battery. Let me just try and send it through there. I wonder, it seems like it needs value 1, 2, and 3, like whether you have them or not. No, the application JSON. Okay, I'm gonna hit test it. Event has been triggered. And I do not have a spreadsheet. So even when I triggered the event, I'm going to unplug my device here. Even when I triggered the event from the IFTTT console, it did not create the document that I was expecting at all. So that tells me that I probably have something wrong with my Google integration. So let's look at that. Google Sheets. And check out my settings. Oh, status offline. Reconnect. Here we go. Here we go. This is our problem. I have to reconnect IFTTT. Now we're active. Okay. So now if I plug back in, it should wait and set it. Wait, 1, 2, and now we should get that document. As soon as it says sent battery level, I feel like this is gonna work. Okay, sent battery level, great. Ah, yes. All right, we got it. And there you go. I guess I could pull this over. You see this? There you go. 5,000. And look at that, it updates live. So that's pretty cool. It's got the date, time, and the value. That's really cool. Okay. And great. Let's watch it update one more time. Yeah, there it goes. Okay, now I'm gonna unplug it. Okay, and now instead of sending just this dummy 5,000, we need to, I'll pull this back over here. We need to read the ADC. And there is some special handling of that on here we go. There's like some calibration stuff. But again, that's all in the ESP-IDF. Let's just do our Google. Read ADC ESP32 Arduino. Oh, I wonder if we could just do the Arduino, like, yeah, just make it an input and then do analog read. Yeah, but see, we don't want to look between 0 and 3.3 volts. We want to go between, and this is nonlinear. We want to read to 1.1, which is the attenuation. Here we go. I think these are what we need. Okay. And we can just do analog read on it. I don't know. Oh, room 32. Okay, so it's actually GPIO. What am I going to read? We have to go back to here. We're going to plug into, we'll just say IO32 or 33. Let's look at the data sheet really quick. IO32, for example, which is this pin right here. IO32 is ADC1 channel 4. So IO32, if we look at this, AC channel 2, what did I say? 30, dang it, it's getting late for me. 32. GPIO 32, so it's going to be this one. ADC1 channel 4. So GPIO 32. So if we do an analog read of GPIO 32, Let's for now comment this out. And while we play around. So analog read, we'll say int value equals that. And let's just do a serial.println value. And we do want to make use of some of these other. Default is 12-bit, that's fine. Set cycles, that's fine. Set samples, we can mess with all this stuff later. This is the real one that we want. Set attenuation. Sets the input attenuation for all DC inputs. Default is 11 dB, which allows you, yes. Voltage of ADC will be attenuated, extending the range of measurement up to approximately 1.1. I thought the default was 0 dB. Oh, is that a swing? We're going to set it to 2.5. We'll play around with these, but let's do. I'll do this up here in setup. And we'll set the attenuation to this. And see, I don't understand what this says right here, because if you set ADC can measure up to approximately 800 millivolts, 1 volt, which is above 800 millivolts, input equals ADC reading of 1088. That doesn't make any sense. That might be a typo. Because on here, 1 volt, the ADC reading of 37, it should, the max is 4095. And so 1 volt in this range would be up in that. Yeah, I think this has got to be a typo. 1 volt. Or maybe it's because it wraps. Maybe that's what it is. Okay. ADC2 pins cannot be used when Wi-Fi is used. 32 is ADC1. Okay, so we're okay. You may consider using an ADC1 GPIO instead. That should solve your problem. Okay. Let's just try and run this, see what happens, see if we get any, like, readings. Oh, let's plug it in. Yeah, yep, we got to put a semicolon there. Pretty standard. Oh, let's upload. GPIO 32 was not declared in this scope. I wonder if it's like that. Okay, it doesn't like my GPIO name. I wonder if it's just 32. Let's try that. Well, it's building. You know what we could do for fun is, oh, it's going to do it every 20 seconds. Well, yeah, it's going to be all over the place, but let's just, let's, let's short it to ground. So it's going to be the third pin over, and then the one right next door is ground. So let's let's see if we can blow this up. All right, so I'm going to plug this into the third one, which should be the pin. And actually now, like when I touch it, it should get different readings as well. Like the potential from me. Yeah, there's 27. And now I'm going to put it right next door. So the next reading should be 0 or very close to it. "20 seconds. 0. All right, great. Okay, I think we're going to call that a stream for today. So I'll just hold this up. You can see all I did was I shorted it together like that. And now it's reading 0, just as I would expect it to. I don't have a... You know what? No, let's go all the way. I'm gonna just hand hook this up and see what we get. Well, I don't have a battery plugged in. Nope. I'll solder that all up. We'll pick it up tomorrow and run it from there. So what we'll do is we'll voltage divide it again, the battery voltage down into that 0 to 1.1 volt range, and we'll read that and we'll send that along. So what we'll do is we'll just take this value and we can translate that value into volts. And so we'll do that. Yeah, we will do that. So we'll translate that into millivolts and send it to our spreadsheet. And then I believe we can do a little bit of magic in Google Sheets to graph it, I think. If not, we'll just export it. We can do it in Calc to graph it to see how that works. And if that all works, we're good. We'll add it to the hardware and we'll make sure it's in our next run. So that's going to do it for the stream today. Bellum, thank you again for dropping by. I hope, again, you found it interesting just writing some firmware this time so we can test the battery. And tomorrow we'll pick up where we left off here. We'll actually test the battery going through a voltage divider. And we will start making our changes, because once we prove that that works, we can go ahead and actually start messing with the layout here to get everything ready to send this off. Hopefully early next week, we can get this order placed to China to get a few of these boards back to test all of the changes that we've been working on. So thanks so much for joining. Appreciate everybody. Hope everybody has an awesome evening, and we will see you tomorrow.